I mean, it's just a different world now than just 100 years ago. And it all correlates with exactly what we started talking about, which is food, food, food. Where did the nutrients go? Where did the medicinal quality of our plants go? Where did the ecosystem go? So we need to really rid ourselves of the belief that we have to outsource to these other mega farming industries and everything else to feed ourselves. We robbed the soil and the plant from the ability to make these essential medicinal qualities.
Your health is in large part determined by the health of the soil. And I know that may seem astonishing for some of you, but we're going to dive deep into why that is. Hi, this is Dr. Mercola helping you take control of your health. And today we have the great privilege of interviewing Dr. Zach Bush, who is, in my estimation, the smartest physician I've ever met. Just brilliant on steroids, essentially. He's triple board certified internal medicine, uh, palliative care, and endocrinology, and he has done some incredible research. It's just innovative, incredibly innovative, and we are just delighted to have him today. And you're gonna, one thing I can assure you with a high degree of confidence, you will love this conversation. So welcome and thank you for joining us today, Zach.
Dr. Mercola, thanks so much for your time and having us on.
Okay, so you have an interesting journey. You were a conventional cancer researcher funded by the NIH up until 2009 and pretty much embedded in the traditional conventional medical model. And then there was maybe it was 2008, but anyway, your funding got cut because of the challenge with the financial collapse and the secondary to the real estate industry in the United States, and NIH restructuring their funding. So why don't you discuss your transition? Because I think that's a really important process of how you came about, some of the concepts
Sure.
that you developed.
Absolutely. Yeah. Definitely allopathically trained from the beginning. University of Colorado medical school, and then after that went to University of Virginia for my postgraduate training in subspecialties of internal medicine, then endocrinology and metabolism. And during the endocrine and metabolism fellowship, I was doing a lot of cellular biology research, looking at novel mechanisms by which cancer cells can kill themselves. And this is novel, at least at the time, and now it's become kind of a mainstay of how we think about the future of cancer management. Is we've always seen it as this kind of battle between the immune system and the cancer cells. Can the immune system find the cancer and kill it? Well, if there's enough cell-cell communication going on, the cancer cells should recognize their problem and commit suicide. We call that apoptosis, which is this kind of programmed cell suicide that happens once the cell reaches a state of damage that it can't repair. So I was kind of in these two halves of my brain, if you will, under the microscope, super left brain, highly analytical, studying all of these very kind of almost in the weeds protein pathways on cell signaling. And then over in clinic, I'm dealing with the macro problem of one of the most extraordinary explosions of disease this human planet has ever seen. We were seeing this explosion of type 2 diabetes, obesity, metabolic collapse, cardiovascular disease, and of course cancer. And so the clinical environment was much different, a lot more right brain creative needs in that clinical environment where you're trying to do troubleshooting all the time. And it ended up being my patients that ended up kind of changing my 17 years of intense academic training in cellular biology to start really thinking, there's got to be a better mechanism by which to do this. And a lot of this is just the journey of any physician. We go in with such excitement into our training. We have such altruistic, expectations and beliefs that we're going in to really help humans be healthy, heal disease. We're going to be equipped with all of these incredible pharmaceutical tools, incredible technological breakthroughs, incredible imaging and diagnostic skills and technologies behind us. Just, we are so empowered, we're so heady. And especially when I was training in the 1990s, we thought we were just around the corner from personalized medicine, where we would just pull a hair or do a mouse swab, send off your genome, know exactly what diseases you were likely to have and which drugs would work to treat them. It was a heady time. And unfortunately, it was, the beginning of the end of Western medicine, and I didn't know it yet. And so what was happening in clinic was that now we were seeing this huge epidemic disease. And here I was, an endocrinologist, a specialist in metabolic disorders like diabetes and the like. And I was using more and more pharmaceutical drugs to kind of tackle this problem. And any physician who's equipped with these big, powerful tools and then employs them, it doesn't take long to start to realize there's huge downsides of the pharmaceutical approach. There's huge limitations to our efficacy, and there's enormous toxicity. And it was really that journey of finding out my patients were looking great on paper. Blood sugars could come down, but they were getting worse clinically. More edema, more weight gain, more fatigue, more depression. Every ounce of insulin I put them on was more disease. And so it was just this, catch-22 situation. So it was my patients that started to help me out of that trap, or out of that box that was, as a human being, starting to get me very depressed. And it was really these root cause questions my patients were asking that I felt incredibly unequipped to answer. I had been a chief resident, kind of, top of the teaching heap in academia. I thought I knew all of the minutiae you could possibly know on diabetes. I trained at the third best endocrine program in the world. My goodness, I was at the top. And yet when they came and asked, why do I have type 2 diabetes? I would go into this detailed description of fat in the liver and insulin resistance and everything else. And they'd say, no. Why do I have type 2 diabetes? And that started to be questions I couldn't answer, because by this time we knew it wasn't genetic. There's some predispositions to it, but we know that you cannot have an epidemic of a genetic disease. Impossible. And so we knew we had an environmental factor, and I didn't know why. And so they started asking those tough kind of root cause questions of why me.
Yes, indeed. And you had mentioned the apoptosis concern is one of the signaling mechanisms for cancer, and that's just reminding me that's one of the reasons why we resonate so well, because I've listened to you quite a bit now. There's not one statement that you make that I disagree with. I mean, we're totally in synchrony on this. And the the apoptosis is really regulated by the mitochondrial health, and much of what you're discussing all focuses back on mitochondrial health. But I'm wondering if you can expand on how this frustration with these many years of highly educated academic work and failure to respond to simple questions from your patients, so what was the next step in that conversion process?
Excellent. Yeah. So, I say the cracks in the glass ceiling of my world were starting to form when they were coming in with these tough questions. And ultimately they had an intuitive knowledge that the nutrition they were eating, the food they had, must have something to do with it. And I kept sending them to the diabetes educators who would teach them a low carb diet. Well, it turns out that type 2 diabetes is not caused by carbohydrates.
Well, at least it wasn't even a low fat diet. That was good.
Right. Well, no, it was absolutely. It's the cardiovascular metabolic. So go low fat, go low carb, which leads you with what? Protein, which is the most acidic thing on the planet, it turns out.
Probably more toxic than both of them.
More toxic than both.
In excess. In
excess, exactly. And they were certainly eating that in excess. And so some of the red flags that were going up is my patient would come in and say, I did see the diabetes educators and I'm 100% compliant with a diabetic diet. And I was like, wow, 100% compliant with a diet. I've never seen that. And these were patients who are on Medicaid, fourth generation poverty in Central Virginia here. And they were 100% compliant with the diabetes diet. And I said, wow, explain how that's possible. And they would pull out their packet and there was a list of acceptable protein sources, and it so happens that hot dogs was down on the list. And so I had these patients that were eating breakfast, lunch, and dinner hot dogs with no buns, and they thought that they were now on a healthy diet because they were eating no carbs. And so this was maybe the first red flag that, oh my gosh, what is this literature we're handing out in diabetes education that hot dogs is even on anybody's list of nutritious foods is somewhat dumbfounding, and that could somehow be interpreted as the only food they should be eating was truly amazing. So those were some of the foundational cracks, but I felt profoundly unprepared to start to enter into that diet or nutrition conversation because I had no training in it. 17 years of higher education in medical science and everything else. And I had a half a semester of a nutrition class in my first or second year of medical school that nobody went to because it was easy to pass by just taking the test. You didn't have to listen to lectures. So yeah, I just was poorly equipped. And I would say that's the vast majority of us doctors, that our education is so slanted away from the lifestyle and so poorly slanted towards this pharmaceutical management of chronic disease. Then really the blinders came off. If you're going to say, what were the stepwise processes to get Zach from a state of, in the trenches down some rabbit hole to some sort of 30,000 foot view of truth, this was a major moment. And what was happening is I was studying these cancer cells under the microscope, and I was running late to clinic. And so had tried to get these things fixed. I got them fixed. I was staring at these cancer cells, and they were invading normal tissue. And you could see this incredible interface between normal tissue and this cancer just invading and penetrating through these normal tissue pathways. Jumped out from behind the microscope, ran across the parking lot, jumped into my white coat, stethoscope, suddenly in my doctor mode, plopped into a seat. How you doing? And the guy says, Doc, I've got this big ulcer on my ankle, and it's a diabetic ulcer in the ankle of this guy. He takes off his boot, and he's got this stinking, kind of festering ulcer in his ankle. And I'm down there in his ankle for about an hour, debriding all of this dead tissue and everything else. And suddenly, 1 second leads to another second. It's like, oh my gosh, this looks identical to the process I was just looking at the microscope. And suddenly all the blinders came off for a moment and said, oh my gosh, there's no such thing as diabetic ulcer. There's no such thing as cancer. There's no such thing as disease. There's only a loss of cell-cell communication. There's only a loss and an isolation and a loneliness that leads to this broken state of repair. And so that, I think, was a huge transformational moment for me to say, there's no such thing as disease. There's only a lack of health. And the lack of health has something to do with this cell-cell communication environment.
Yes, it's kind of like an analogy that I'm fond of and mentioned in the past, is that you can't have light and darkness at the same place. So if you shine a light in the darkness, darkness disappears. So light is the health. So if you have health, you're just not going to be sick.
Dr. McCullough, this is why you are who you are. I mean, to boil that whole entourage of words down to that, you just nailed it. That was beautiful.
Yeah, so it's a powerful illustration that helps people understand that, and I'm grateful for it. So so that was an interesting epiphany that you had, and so this is lack of intracellular communication, and then you have I opened this up with the connection between the soil, and I want to go back to there in a moment, but I wanted to get the foundational primer of your experience to get, so people could have a framework for it. But at some point, I think someone in your clinic or your association brought out a informational pamphlet or a mini book, 50, 70 pages, and you believe you thought there wasn't even that much written ever in the history of the world about agriculture. So, and then you made the connection there. Is that the next step that?
Yeah, pretty much. In 2010, I left academia. You're right. The funding for my research kind of dried up as the NIH collapsed in funding, and the University of Virginia lost its funding for the General Clinical Research Center, where all my research was based. And so academia was kind of in free fall during the recession there, and then jumped out of academia, much to my fear and terror. I was afraid I was never going to teach again. I was afraid I was never going to do basic science again. I really thought I was, the end of 17 years of an academic career. But I knew I needed to go into this nutrition world. And so I started this nutrition clinic, and I wanted to do a plant-based kind of vegan clinic. And I really had a mission to really heal America at its roots. And I was not interested in going to Santa Barbara, California, and making Santa Barbara, Californians vegan. That just wasn't going to heal the world. So instead, I went to the poorest county in Virginia and started this nutrition clinic. And I figured if we could make this work in fifth generation poverty, it would work anywhere, and we might have a chance of changing the public health tide. And so we started there, and for the next 2 years, I kale juiced and pounded my poor patients with more nutrients than I think I tend to go extreme when I go, and
like many of us do.
And so I was just pounding my patients with the best nutrients I could find in the garden, and helping them learn how to grow food and all this stuff. And very frustratingly, there was a good 40-50% of them that weren't responding in the right direction. There was this amazing miracle happening to 40% of them, where conditions of decades were just melting away under the force of nutrition. But then there's this huge percentage, and no matter how much nutrition we tried to bring to the plate, they were getting worse, not better. You try to feed them kale, they get more bloating, more inflammation. Antibodies would go up, not down. And so the big question in our clinic started to become, do we have the wrong science? We're applying science from the 1970s and 80s around nutrients and their impact on everything from antioxidants to mitochondrial metabolism. Is it possible we got the wrong science? And so, as you say, William Vitalis, my colleague that we call the unicorn, he's the guy who brings the magic. He brought in this 90-page white paper on soil science, and as you say, that was pretty astonishing that anybody written 90 pages on dirt. And so, paging quickly through this, patients waiting for me in clinic, and around page 40, there's this big picture of a molecule sitting there that stopped me in my tracks. And I probably could have paged by that thing 1,000 times, but this just was another one of those bumper blocks in life where universe says, stop, look at this. And the blinders came down for a moment. And I said, oh my gosh, that looks a hell of a lot like the chemotherapy I used to be making. What is that doing in soil? And so that was the moment where we really started to turn our attention to the possibility that there was intelligence in the soil.
Yeah, so, and maybe we can expand on that, because there's just so, I mean, one of the crux challenges that we face as a society, a culture, is the fact that we've been incorporating or adopted industrial farming practices for well over a century, and for close to a century, or coming close to a century, and using the synthetic fertilizers, and that is just devastating, absolutely devastating, and decimating the soil. And some estimates are that within 1 or 2 generations, we'll have virtually no topsoil left if it continues. I don't think that'll happen. I think people are going to wake up before it's too late, but we still have to call alerts, make some alerts, because regenerative agriculture is a necessary component. So maybe you can expand on that connection there with what's happening with the soil, and obviously if you don't have healthy soil, you can't create and micronutrients aren't there, they can't be transferred to the food, so you're going to be micronutrient deficient even if you're eating supposedly some of the healthiest foods out there.
You're absolutely right. Absolutely right. And the scenario that we can look back to is that let's go back even before World War II. In my lectures, I often start there, but let's think about the Dust Bowl for a second. In the late 1800s, we changed farming practices, and we had started to disrespect age-old practices of crop rotation, composting, soil rotation, soil aeration, all of this, and we started to kill topsoil in the Midwest and through the kind of bread belt of America.
And the Midwest had some of the best topsoil and the deepest topsoil in the whole world.
In the whole world, exactly right. And so we had the richest biome in some ways to work with there, incredibly rich fungi, bacteria, this ecosystem that was rivaling a coral reef or a Costa Rican jungle, just massive ecodiversity in these, 3, 5, 8, 12-foot deep layers of soil that were in the Midwest at the time. And then we started disrespecting that age-old practice of farming respect, and the soil started to die, and we ended up with the Dust Bowl. So we had, what used to be this living soil that was vibrant and connected to dead soil that was now blowing through the air and covering whole towns in dirt. It looked like Pompeii. And then, of course, the Great Depression is happening. Everything is looking pretty desperate. And then World War II starts, the Great Deal with FDR and everything else. And that kind of rejuvenates the economy by this huge petroleum industry that got revved up, and this huge mechanized machinery of getting the war machine sped up. So we were building, steel factories, everything. Pennsylvania was booming. Pittsburgh was the steel capital. Everything was just boom, boom, boom town, but it didn't have anything to do with food production. It didn't have anything to do with getting nutrients back into our soil. So then World War II wraps up. And at the end of that moment, it's just a fascinating look. And this is probably the most important data point we can have as consumers to take back to big farming industry to say you're wrong, because they keep defending their practices by saying, well, we can't feed the world if we don't use chemical farming. And you would say, no, we fed the world perfectly from the backyard gardens of our victory gardens that FDR and Eleanor Roosevelt pushed everybody to do during the war. And so at the end of World War II, we were growing 45% of our American food chain in the backyard. 45% of the food chain. Now we're growing less than 1,000th of 1%.
Well, that's in the U.S., but worldwide, I believe 70% of the farms are small farms. I mean,
Absolutely.
Literally 1 or 2 people.
Yeah, exactly. And those practices that they're doing were handed to them by their grandparents and their great-grandparents and their great-grandparents. So there's this lineage, or there's this complete incredible history that's really put into place there. That's just a profound environment for us to tap back into. So we need to really rid ourselves of the belief that we have to outsource to these other mega farming industries and everything else to feed ourselves. And then there's, of course, we'll get into the GMO story later, but let's take a look at this plant health, because it so correlates and so parallels human health. So in 1945, we start, coming back from the war, we have this huge glut of petroleum. And with that glut of petroleum, we no longer are putting that into the Jeeps and the tanks and everything else, and so it gets cheap. And so the industry needs a new avenue for that. And so they create the nitrogen fertilizers from oil. And so suddenly, instead of, saying, hey, we need to go back to soil respect and start respecting the biome and getting bacteria back involved, instead we said, oh, this is awesome. We just dig out oil from 100 million, 100 billion years ago, and then we spray it on our fields, and then we have green crops. Well, fine, you may have a green crop because there's plenty of nitrogen and phosphorus there, but there's not going to be any selenium, manganese, any of your trace micronutrients in the soil there, and you're not going to be respecting and asking that biome to wake back up and move forward. And so that was now the setup for the sickness of our plants. And so it's so interesting that when you have a plant in your backyard or a mega farm, if it starts to lack nutrients, the first thing that happens is pests come. And so those pests can come in the form of viruses, can come in the form of parasites, can come in the form of fungus and yeasts, and they kill the plants. And so suddenly we had this huge demand for chemicals to come in and be antibiotics basically for our plant kingdom. And so we started spraying and spraying and spraying. And of course, we've seen the same parallel in humans. The more antibiotics you use, the more drug-resistant bugs, the loss of the ecosystem, the worse the disease gets. So then the granddaddy of them all came in 1976. And so to put this in context by poundage, we'll do in a minute, but I hope we can quickly convince all of your listeners that there is nothing that competes with this single chemical that came out in 1976, which is glyphosate. Glyphosate is the active ingredient in the vast majority of weed killers on the market now. Previous to 2007, when it came off patent, it was really known worldwide as Roundup. And Roundup came out in the 80s as a direct-to-consumer market. And so this is a very potent chemical that kills plants. And it, so you don't want to kill most of your plants, so it's called a weed killer. But in reality, any plant you spray with it is going to kill. It's worthwhile noting why it kills plants. It's not like alcohol that just simply is a potent oxidant and kills it. It's a pretty tricky and actually in the end very frightening approach to killing a plant. What glyphosate does is it blocks an enzyme pathway in the plant or in the bacteria that is called the shikimate pathway. And these enzymes are responsible for making some of the most important compounds in food. Some of these are the ringed carbon structures that are the backbone of hormones, such as tryptophan. And so if you take away tryptophan from the plant chain or from the plant kingdom by killing this pathway in bacteria and plants, now the plant can't make these essential signaling molecules and everything else. It wipes out actually about 4 to 6 of the essential amino acids, which are the building blocks for all proteins in your body, which can be enzymes, they can be signaling proteins, all kinds of things. So it wipes out amino acids that are going to be the building blocks for your body. There's only 26 amino acids. You take away 4 to 6 of those, my gosh, you just lost a huge percentage of biology there. But then that's just the beginning of the problem when we're talking about nutrition. And this is, I really believe, the answer to why were we feeding all this healthy food to our patients in clinic and not seeing the health benefits. And it's a family of compounds that's called the alkaloids. If you haven't ever heard of the alkaloids, it's worth a Google search and just look these things up. And then as you read through that list, now imagine what would happen if we removed the alkaloids from our food. And what you see exactly is the disease burst that we have going on across so many organ systems in our bodies. The alkaloids, there's a family of them that are antiparasitic. We have an extremely huge explosion of Lyme disease in my area of Virginia, obviously most of the country and large parts of the world. And so we have parasite being overexpressed. They are anti-diabetic. They are anti-cancer. They are anti-hypertensive. They are anti-mood disorder. They function as mood stabilizers, antidepressants. You know, it goes on and on and on down the list. They're anti-asthma, you know, anti-eczema type compounds. You go through the list of alkaloids and you're like, oh my gosh, if we added a chemical to our food chain that wiped out all of the production of this in our food, we would have just lost the medicinal quality of our food that has existed for thousands and thousands of years. And so it's an astonishing story of just
So
almost
the alkaloids are a class of
class of
substances. So do the
compounds. Yes.
polyphenols fall into those classes? That class, the
I'm
alkaloids?
sorry, what was the question?
Did the polyphenols fall into that class?
Polyphenols. Yep, that would be an example of one of the chunks of families in those. And these are extremely active compounds. I mean, these are right up there with redox molecules, which we'll maybe talk about
Yeah,
in
we
another
need to talk about
segment.
that.
But they're so fast in their signaling mechanisms, and it's interesting that, you know, Johns Hopkins just came out with a really nice review article for the lay public recently on asthma, and for the first time we have this huge, you know, respected university saying that asthma is not a disease of the lung. What? that should be an eye opener for doctors, if not consumers. It's not a disease of the lung. It is a disease of the small intestine. Why? Because as soon as you lack the bacteria there and you start to get this permeability of the gut and you lack these alkaloid factors that are coming from the bacterial biome, you are now inducing asthma from this gut inflammation. So just, you know, we could pick off all of them: cancer, heart disease, all of these diseases. We're really focusing in on, oh my gosh, we robbed the soil and the plant from the ability to make these essential medicinal qualities.
Yeah, so you had mentioned that the glyphosate is one of its primary mechanisms of action. It has multiple, of course, is it blocks the shikimate pathway. And we're told by Monsanto and other people who manufacture it now that this only happens in bacteria, so it's not a problem for us because we're eukaryotic species. So why don't you elaborate
Right.
on that and explain why the falsehood of that assumption?
Right. And so you can see how a marketing team could grab this and say, oh, great. Well, how it must be so safe because there is no shikimate pathway in humans. Except the minor detail, humans can't make their own alkaloids. Humans can't make their own essential amino acids. They have to get them from the plants that feed off the bacteria in the soil. And so suddenly you realize, wait a second, their argument is the very problem. Yeah, it's the very essential nature of the idiocy that we did as a human species when we said, oh, well, we can't hurt the human. How egocentric is that? How narcissistic could we possibly get as a species to say, well, since it doesn't hurt humans, we must be good to go? Because we don't need those 1.4 quadrillion bacteria that might be taking care of us and providing all of the nutrients we need. We don't need those 14 quadrillion mitochondria that are fully responsible for taking all of the food on the plate and turning that into the only molecule the human cell runs on, which is ATP, or adenosine triphosphate. So, you know, I have to laugh because it's so freaking sad. It is so pathetic that we did this to ourselves. And so it is just so myopic. It was so ironic that we thought, well, we're bulletproof and we can't hurt humans, therefore we must be good.
Well, I wouldn't be so quick to criticize the whole species because it was this very small group of greedy corporate individuals who really wanted to earn money, could care less about harming the biology and the whole human ecosystem. But I want to connect some of the dots because you had mentioned earlier about the intercellular communication as being at the core foundational root of all disease, and it really is a disease. It's the loss of this intercellular communication. So let's tie that into the glyphosate and how that disrupts intercellular communication.
Yeah, so, you know, it sounded bad with the alkaloids, but it gets worse from there, unfortunately. And so this is a slippery slope of bad news biochemistry here. So you're about to hear why I don't get invited to any parties anywhere, anytime. Nobody really wants to hear this information. But all right, so let's... I guess let's paint one more picture before I jump into the cell-cell communication so that we can maybe paint a backdrop, because we're not trained, certainly as consumers, let alone physicians, to think about cell-to-cell communication on this level. But let me just paint the backdrop of the bacteria for a moment. We've been talking about nutrients and the lack of nutrients in our plants, but let's back up again to World War II for a moment and say, what's been happening to our ecosystem, or the bacteria that are thriving historically in our soils, and now we have the opportunity to either miss them or participate with them. In the early 1940s, we discovered penicillin. Penicillin, you may recall, is derived from bread mold, which is an interesting story of ecosystem, right? If mold kills bacteria, what do you think bacteria might do to mold? If mold kills bacteria, what do you think it might do to a parasite? You know, and suddenly you see, like, if we're going to have 40,000, 100,000 species of bacteria, fungi, viruses, all these things in concert, they're going to have to check each other's growth. They're going to have to be able to balance and do the yin-yang thing. So penicillin was the first thing where, again, we overlooked the profound truth here, is that, wow, bacteria and fungi are in relationship. Instead, we said, oh, what a great chemical. We could extract that. We turn that into a drug, make billions of dollars. So we extracted the chemical, made a drug, penicillin, reserved for the troops during World War II because we couldn't produce much of it. And it was going out trying to prevent gangrene and important things. And it was a big paradigm shift to be able to kill bacteria. And so previous to that, it was alcohol, it was antiseptics, things like that. Now we had this mercury. Yeah. yeah. I'm sure you've never done a spot on heavy metals in your show, but so this is the backdrop. So we started to kill bacteria, but of course World War II wraps up and we start to amp up our ability to make penicillin, and pretty soon everybody's getting a shot of penicillin for anything they came into the primary care doctor for. You have a cough, injection of penicillin in the butt. You got sore elbow, injection of penicillin. You got cancer, injection of penicillin. Just didn't matter. So suddenly we were penicillinizing everybody, and we were drugging it up. You fast forward now to 2011, 2012. This is the last time I have hard numbers on the number of prescriptions given in the United States for antibiotics. By this time, and actually that line has been pretty flat, the number of prescriptions per 1,000 persons in the United States, it's been pretty flat for the last 10 years. And that number is around 7.7 million pounds of antibiotic prescribed to Americans every year. I mean, that's pounds, not prescriptions. It equals out to over 800 prescriptions for every 1,000 persons. What? Yeah, 80% of the population is seeing antibiotic in any given year? The answer is yes. And so the reason the line has been flat, we haven't increased beyond that, is you actually physically can't get enough antibiotic prescriptions into people's hands to surpass 83% of the entire population, because somebody was actually busy and did some work or something like that and didn't get to the doctor to get their prescription. And so we've maxed out our ability. Now take a look at what's happening in our agriculture industry. Starting in the 1960s and really ramping up through the 80s, 90s, we've been putting antibiotics into the feed to induce stress in the animal, which makes it store fat and gain weight faster and then get to the butcher block quicker. So that stress induction of antibiotics has been used for a long time now in meat production. Not surprisingly, the United States wins worldwide as the most number of milligrams per kilogram of meat produced, and it's pretty gross. By 2011, 2012, we're looking at 300 milligrams per every 1 kilogram of beef. So 1/3 of the weight of the cow is prescribed in antibiotics in some shape or form. Disgusting. That equates to almost 30 million pounds. So it was 7.7 million pounds for the human consumption. It was 30 million pounds for the cow. Now take a look at glyphosate. Currently, we're using over 2 billion kilograms of glyphosate worldwide right now.
Is it annual, isn't it?
Annually. And that number doubles every 6 years for the last 25. And so it's so, and that's an antibiotic. That's functioning to kill bacteria in the soil.
That was its original patent, was for an antibiotic.
It was an antibiotic. It's been patented as an anti-parasite. It's been patented as an anti-malarial. I mean, it just goes on and on and on as to kind of their recognition that this thing kills bugs, you know. And so now, of course, you know, the disaster we have is we're dumping 2 billion kilograms into our soils of the earth, which means all of that soil now cannot produce alkaloids, it cannot produce any of the critical amino acids for those 6 amino acids that are critical to protein building.
Just interrupt you here. For those who aren't metrically inclined, 2 billion kilograms is 5 billion pounds. If you're using the imperial system.
Yeah, it gets pretty gross pretty fast. And the devastating thing about glyphosate compared to something like mercury, which you mentioned earlier, so most of the heavy metals and other toxins that are in our environment are going to be pretty lipophilic. They're going to prefer a fat environment. And that's going to actually keep them relatively sequestered in our ecosystem. You don't find much mercury in the air, for example. It's going to be sequestered down into our water, our systems. So you could find some in water, but it's not going to have a hard time transiting into a cloud. Glyphosate, unfortunately, is an organophosphate. Oh, I didn't even mention this when we're talking about amino acids. Glyphosate is called glyphosate because its backbone is glycine, which is one of the most essential amino acids that's extremely rich in your extracellular matrix, which we will come back to in a few minutes. But your extracellular matrix, your neurons, many tissues of your body rely on glycine as an amino acid building block. Well, glyphosate is glycine with a phosphate tagged on the end of it and an amine, which is a carbon-oxygen compound on the other. So this whole family is called organophosphates. Organophosphate molecules are a toxin that tragically is water soluble. This is like, for a biochemist, this is like goosebumps. This is Dante's hell opening up right there. Because if you have a water soluble toxin that is 2 billion kilograms in the environment a year, you know it's now infiltrated every sector of the water cycle. And that's exactly what we're finding. Recent studies done down in the southern United States, 75% of the rainfall, 75% of the air samples contaminated with glyphosate. So we're dumping it into our soil, goes into the water system, runs off into our rivers. Some of it settles into our deep fossil aquifers that have been cleaned for billions of years, are now contaminated. And so we've got all of that contamination underneath us. And then you get the mobilization of the water cycle. You get evaporation, you get clouds, you get rain, and in every single part of that cycle, you've got glyphosate, which is a devastating story about our food chain again, of course, because as consumers, we are waking up to the reality, we have got to get organic. We got to get these chemicals out of our diet. And so we're eating organic food. We're doing all this stuff that we can at the grocery store. And yet, if it rained on that crop, you've got glyphosate. Now, obviously, it's going to be way less than if the farmer just came and sprayed glyphosate all over it right before it harvested. But nonetheless, we have this whole ecosystem contaminated with a single chemical that is an antibiotic. We are annihilating the ecosystem around us and our health by this beautiful checks and balances Mother Nature that we live in. I think this is by her intention, right? This is not a mistake that we were relying on the rest of the ecosystem for our health, because this made sure that if we started to misbehave and we started to disrespect our environment, our health would diminish. And now our health is diminishing to the point where we can't reproduce. And so we're going to see a flattening and a collapse of the human population if we don't change directions very quickly with the way in which we're disrespecting our ecosystem.
Yeah, can you comment on the concentration that is in the average person of glyphosate, even if they're, I guess there's two subgroups: the normal individual and then those who are seeking to avoid anything but organic foods.
Yeah, so you'll definitely see a huge range in there. And this is water soluble, meaning that it's very hard to measure by the second as to how much is in your total body, because it's dependent highly on what compartment you check. And so you could check the blood level of glyphosate, and that's not going to necessarily reflect what's intracellular. It's not going to reflect what's the kidney is seeing and in the urine, etc. And so it's going to depend on where you check that. But we can go right back to the manufacturer for this information, basically, because the manufacturer has been saying the one thing you said, which is, well, this doesn't have a cellular pathway in humans, so it must be safe. Well, we're going to prove that that's not true. There's other toxicities direct to the human toxicity that we'll talk about. But, bigger story than that, around the nature of the glyphosate in its compartments is that Monsanto's been saying it's never bioaccumulated, which was an important piece of their safety data, that the body doesn't store this stuff. Well, that was reassuring to the EPA and the USDA and everything else. But if you looked at their data, they said, look, at the same rate that you eat it, you're going to pee it out. And so if you measure how much is in the food, you're going to see about that much in the urine. And so if we take a look at the food chain right now, it's typical to be exposed anywhere from 1 part per million up to as much as 40 parts per million of glyphosate in a typical diet. And so you can say with confidence that the human body is going to have anywhere from that 1 to 40 parts per million of glyphosate in its aqueous environment. Now, there's exceptions to that, and a desperately sad one got exposed by a nonprofit. Zen Honeycutt is, I think, one of the heroes of the consumer industry. She runs Moms Across America, which is a nonprofit consumer education mission-based organization out of Colorado, and just a beautiful woman in an organization that with a really great passion and message. They had been asking the EPA for decades to do a glyphosate in breast milk study. And in 2014, they finally raised enough money to do the assays themselves. So they had women who were trying to stay away from Roundup, trying to stay away from glyphosate, submit breast milk samples to the study. They had 10 women in the study, and I think it was 5 of them had detectable glyphosate levels. 3 of the 10 had levels that were logarithmically higher than ever measured in the human body before. And so sadly, we were looking at 760 to 1,600 times the amount of glyphosate that's allowed in European water systems sitting there in the breast milk. This is a devastating story for neonatal life, in that here you have an infant that just got born, and unfortunately in the United States, 47% chance that kid got born by C-section, which means never saw the ecosystem of mom's vaginal canal, is born sterile and immediately adopts hospital floor, not mom's floor. So you have a very narrow ecosystem in this infant, already deficient in this bacterial communication network that we'll talk about, and then you put it on mom's breast, and boom, glyphosate, 760, 1,600 times the amount that you would see in the drinking water in a European city. So just a devastating story. Now, we can get now, I guess, into the story of what is the direct toxicity of glyphosate in that human. But am I missing any pieces before I go forward?
No, it's great. It's a good story. I think
right.
Everyone's hanging at the edge of their seat to hear the next part of it.
It's nice to be famous. Somebody wants to hear what I say somewhere in the world. So it may not be the cocktail party, but on Dr. McCullough's show, it is frontline seats. So thank you. So this was, stuff that I didn't know anything about. Extracellular matrix, the whole protein structure outside of cells, was not in my purview. Here I was studying cells at the highest level of detail, and I was all stuck inside the human cell. And so that changed once I left UVA, started in the nutrition environment, and then we found these bacterial communication molecules down in soil in 2012. And what we then found is we started to study the effects of this communication network in the gut and environment, small intestine and colon, is we started to realize that there was a direct toxicity of glyphosate that was linked very closely to the presence or the lack of bacteria. And so this was starting to suddenly bring a bunch of pieces of the puzzle together. And the damage we were seeing had been published by other people, but we were seeing it happen in such an interesting fashion when you put it into play with the bacteria. And so what we are seeing as a direct toxicity effect of glyphosate in the human environment is its direct damage to a protein structure in the gut and any other membrane in the body. This protein is called tight junctions, and it has multiple constituents, multiple little proteins that make up these large Velcro-like proteins that hook together and attach one microscopic cell to the next cell. And in the example of the gut that starts at your sinuses and goes all the way to the rectum, you've got a situation where you have a vast amount of, really trillions of cells that are making up a single cohesive carpet or membrane or shield from the outside world.
Ideally.
Ideally. And so that membrane that's now laced together with the Velcro is your front line of defense. And under a microscope, it gives me goosebumps on a daily basis to look under the microscope to realize how thin a veil protects us from this outside toxic world we live in. It is a single cell layer thick. This is many, many, many fractions of the width of a hair is this tiny membrane of single cells, not 2 or 3 cells stacked, one single cell attached to the next. And it's that ethereal, almost invisible membrane that's held together by the Velcro that is your front line of defense. The Velcro, it turns out, is loosened appropriately by biology to allow big macromolecules to come in, and then it tightens up right behind that. That is managed by a little protein that we make in our own body called zonulin. Zonulin is produced appropriately by molecules that need to get through the membrane, and so it'll touch the membrane. The gut epithelium will make zonulin. The zonulin will open up the tight junctions, kind of like the doors on the side of the Enterprise or something like that. The big gates open and the little spaceship comes in and the doors shut right behind it. That's what's supposed to be this intelligent gut membrane. It opens, allows through, closes, keeps everything else out. So zonulin is this critical modulator of this permeability of the gut membrane. If zonulin starts to get overproduced and you can't check its production, it starts to become its own problem. It starts to lead to damage in the gut epithelium to the Velcro, and suddenly everything starts opening up. All the gates open, and everything that was supposed to keep out is let in. Your sinuses, think about this. In the 1920s, 30s, 40s, was everybody walking around with a nasal spray because they were all congested and had seasonal allergies? No, nobody. You go right now to the Philippines or the developing world, you don't see people with chronic seasonal allergies or any of this stuff. It's because if we're not breathing glyphosate, if we're not breathing this chemical that induces zonulin, breaks the part, the Velcro, induces all this, then everything system works. We can breathe pollen all day long if the Velcro is tight. Velcro falls apart. Now, every breath you take, you're insulting your immune system with all this stuff that should have been kept outside the system. So it turns out that zonulin is triggered very potently by glyphosate. What a sad story, because we just mentioned that Monsanto and other companies have been telling us, hey, it's safe. You eat it and you'll pee it out at the same rate. Oh my gosh. That's really bad news, because now you have to not cross just the gut membrane. You have to cross the membrane of the hepatocyte, the liver cells, go from one bloodstream to the other. Then you have to go into the bloodstream. All the blood vessels are tied together with tight junctions. Now you go to the blood-brain barrier, tied together with tight junctions. That starts to leak. The brain's being exposed. Then you get to the kidney, the critical organ for detox. It's tight junctions. So it starts leaking, and you can no longer build gradients to pull toxin out of the body. And suddenly you're leaking at the gate, and you can't detox. The body just became a sponge for toxins, and you live in a toxic world. This is how we have a disease rate like we do today.
That's a great story. But before we go into to tie up the story with the intracellular communication, I want you to just talk about disease rates, because I've been in your presentations where you mentioned that, and I think it's frightening if we don't do something about this. And we're not here to paint a picture of doom and gloom, because there are solutions that we can do, and we'll touch on them here. I mean, to do a whole, we do 2-3 hours on solutions, but why don't you discuss the disease rates that we're seeing now?
This is so sobering, and there's just no two ways about this. And it's absolutely the motivator behind my whole company and all of us that wake up in the morning to go pour our energy into more discovery, more, turn over more stones, ask more root cause questions, because this is really the end of our species as we understand it. And so let's take the example of autism, which is probably the most stunning, but in fact, it's actually not the most prevalent. But its prevalence and the change of its prevalence is stunning. In 1975, the year before glyphosate debuted, we had a rate of 1 in 5,000 children born with autism. Right now, we have a rate around 1 in 42 children born with autism. 1 in 5,000 to 1 in 42 in one generation. Technically it's 2 generations, but this is, I've been alive since then. So my one generation, I've seen that kind of explosion. Now there's many people.
That's the year I started medical school.
That's the year you started medical school.
Yeah.
And so in one medical career, you watch autism go from 1 in 5,000, 1 in 42. Now you can go to the CDC's website, and you can go to, Stephanie Seneff and many others in the private sector who are doing the same math. But you go to any source and watch what happens to this asymptotic curve, this trajectory of this vertical curve that we're now on. And what's going to happen is somewhere between the year 2030 and the year 2040, 2045, depending on whose graph you read, you're going to hit a rate of autism in the 1 to 3 range. This is a statistic that now makes it impossible for human productivity to occur. An interesting tactic that happened in Vietnam was that they were using a small caliber bullet in Vietnam, with the philosophy that killing a Vietnamese Viet Cong soldier was not as helpful or debilitating to the Vietnamese as injuring that soldier. And what they showed, and this was complex math that determined this, and how to cripple a nation the fastest was for every one injured person, it took 2 people to care for them. And so if we are looking at 1 in 3 with autism, you now have 2 people taking care of every autistic child. And by Vietnam statistics, you just wiped out any possibility of leaving some sector that's still productive. So if you just look at it from a pure financial standpoint, we have no financial solubility as a species beyond this 2035, 2045 range. Now we're going to waste 8 years with the next, presidential, Senate group, everything else. There is no time for us to wait for legislation. This is why, Dr. McCullough, what you do is so flipping critical. Is because if we don't have doctors out there, if we don't have scientists out there, if we don't have consumers like Zen Honeycutt and Moms Across America and these consumer groups, if we don't band together and hurry up and get this message out there that we have to stop spraying glyphosate right now, we're doomed. And so
but it
that's
gets even worse,
autism.
right? Or it gets even better or worse, because I mean that's a pretty dreary picture that you just painted. Yes. But that's on the beginning stages of life. We are on the end stages. I want you to talk about that because we have a tsunami of Alzheimer's coming. So you've got all these autistic children, and you have parents or grandparents who lost their mind. So why don't you expand on that?
Lucky, if they're lucky, they'll live long enough to lose their minds with dementia. Unfortunately, that's looking unrealistic. If you've heard the recent news, the deaths from Alzheimer's has actually decreased in the recent 4 years. Why is that? They're touting that as, oh, this is the first good news we've seen in dementia. Well, the reason is because they're all dying from cancer before they can get dementia. And so dementia was always historically the disease of the healthy guy that lived long enough to finally have dementia. And that's exactly what we're seeing. So cancer rates are exploding. Cancer Alley is the last 90 miles between Baton Rouge and Louisiana and New Orleans. That 90-mile strip, now if you look at the entire Mississippi River tributaries in the United States, it literally grabs some 85 or 90% of the molecules of glyphosate sprayed and consolidates it into the Mississippi River and dumps all of that spraying into the last 90 miles of the Mississippi, and that's called Cancer Alley. That is the highest rates of cancer in the entire world. And so what the heck are we doing there? But it goes obviously across the country. 1 in 2 males in the United States will now get cancer before they die. 1 in 2, and this doesn't even count skin cancer. Skin cancer numbers are absolutely astronomical, but 50% of males will now get cancer before they die. Women are just behind us, 1 in 3-ish. And so we have got ourselves an epidemic of cancer. And of course, sadly, in my clinic, I see this almost on a monthly basis now. We're seeing some kid come in with some horrible cancer, sarcomas of the bones, or chronic bone marrow cancers. All these things that used to happen in 70 and 80 and 90-year-old people are now happening in 5-year-old children, 3-year-old children, and not even to mention the whole brain tumor epidemic that we have going on in children. They're trying to tell us that there's no increase in brain tumors. Well, for the entire population, those statistics are barely hanging on to be true. But if you just take the children under the age of 20 and look at how many kids had GBM under age 20 in 1976 versus now, it's just like the autism scales. It's a boom. And so we have ourselves a disaster of cancer. And so now you can chart out everything else in between the first moments of life, the first year and a half of life with attention deficit disorders, sensory processing, the spectrum disorders, autism, to the ends of life with dementia and cancer, and then everything in between. 1 in 10 kids has attention deficit disorder now, and unfortunately 70% of them are medicated. This is just an extraordinary statistic. And then 1 in 4 kids now has some sort of food or environmental allergy. 1 in 4 has eczema. 1 in 4 has asthma in Australia now. Australia is actually beating the U.S. in asthma rates. And so it's just, one system after another. And of course, the mental health one, we're now at 1 in 2. 1 in 2 adults will have some sort of depression or bipolar type phenomenon during their adult life. That is in contrast to a prevalence in 1900 of 1 in 100 adults. And so just I mean, it's just a different world now than just 100 years ago. And it all correlates with exactly what we started talking about, which is food, food, food. Where did the nutrients go? Where did the medicinal quality of our plants go? Where did the ecosystem go? So now let's just paint this all back to an amazing story of communication.
Right.
And this is, exactly what you're doing with your show, is get the words out there, change the public dialogue. Let's get people mobilized together to change the industries. What we found in 2012 is a bacterial communication molecule. And there's a lot of complex biochemistry we could dive into, but I'm going to just boil this down to a nutshell that the word redox means reduction and oxidation. The simple concept of reduction is the donation of an electron to an environment. Oxidation is the tearing away or removal of an electron. The most common oxidation that you're used to seeing in the lay environment when you're not under a microscope is rust. And so if your car bumper starts to rust or whatever it is, it's literally oxidizing. The water from the environment is tearing electrons off of the steel, and it's oxidizing. And you can see what happens. It becomes diseased, right? It's all calloused and it's falling apart and it's starting to erode itself. And pretty soon the rust becomes its own source of oxidative stress, and it's destroying the metal at a very fast rate itself. Same thing happening in joints, osteoarthritis, that's the rusting of a joint. We could go on down cardiovascular disease, that's the rusting of the vascular tree, all of these different systems. What we discovered in 2012 was a redox molecule potential in soil made by bacteria. This was earth-shattering for my brain because all my cancer research had been in mitochondria. Mitochondria look a hell of a lot like bacteria, but they're about 1,000 times smaller. And they live inside your cells. And your cells are booming with the population of these mitochondria when you're born. Your neurons can have 3,000 mitochondria in a single nerve. The average across the whole body is about 200 mitochondria per human cell. 14 quadrillion mitochondria. I mean, just massive numbers. Those mitochondria, when they digest your food, they make balanced signaling of redox molecules. And it's those redox molecules that I was studying to say, wow, we can use this communication network to empower a cancer cell to induce apoptosis or program to cell suicide. And so that was my world of cancer. I was like, oh my gosh, mitochondria rule the world of the cancer cell. If they make enough redox molecules, if they can get high enough oxidative stress in there, the cell will kill itself. Then fast forward 2012, suddenly, what is that molecule in soil? Why is there redox potential in the soil? And then, of course, the bacteria don't have mitochondria. Only multicellular organisms like the eukaryote that you mentioned, the humans or a multicellular mammal or whatever it is, we have to have mitochondria because we can't break down nutrients from the food by ourselves. We need the mitochondria to do that. Single-celled organisms like your bacteria, they don't need mitochondria. They can take all of that and they do their own metabolic breakdown or fermentation of whatever's in our environment. And so the bacteria don't have mitochondria, therefore they don't have all that redox signaling. How the heck would they balance an ecosystem of 40,000 species if they can't talk? So the goosebump, blow my mind moment of 2012 was, oh my gosh, they're talking. The bacteria are speaking together. They are in communication. They know what balance looks like. They know how to change the system.
So it's a disruption, and indirectly, if you can tie that back into the glyphosate and how that disrupts intracellular communication. I mean, it's
perfect. So to our shock, amazement, and joy, and I'm so glad to be able to tell you this is all going to end on a good note, or at least an opportunity for us as humans to heal here. But the extraordinary thing that is unraveled, and I have to just bring up John Gilday here. He is one of the most brilliant PhDs on the planet, and I have the joy of working with him on a regular basis. And he's just a genius in our lab environment. And he literally, in a thought experiment, figured out everything that we've now proven over the last 4 years. He figured out that the machinery of our bacterial communication network that we have found was going to be the antidote to glyphosate, specifically at this Velcro permeability problem. And so he put that into play immediately. We did small intestine and colon and all the rest, and it blew his mind, it blew our minds, it changed the way we think about biology completely, because for the first time we were studying human biology in the context of a fluid, fluent, robust, bacterial communication system. We'd never seen human cells in that environment under a microscope. It changed everything we believed about apoptosis, changed everything we thought about protein synthesis, genomics. I mean, it just goes on and on now. Everything that we know about human physiology, I don't care if we're talking about cancer research, cardiovascular research, exercise physiology, human nutrition, it's been studied in a petri dish that is sterile. We literally do not know what the most basic mechanisms of health are in the human system because we've never studied it. We never took into account the possibility that an ecosystem of fungi and bacteria could be dictating human cellular behavior and health. To give you an idea of how out of control their contribution is this new story of microRNA. So many of you are familiar with epigenetics, when we suddenly, unfortunately, realized in the late 90s and 2000s that, oh no, we decoded the human genome, but the bad news is the genes are turning on and off and making many, many different proteins based on their environment, not based on the genome. A single gene is now recognized to be able to make 200 different protein products depending on its environment. This was a total paradigm shift and really bad news for everybody who was banking on personalized medicine, because it now meant that the genome meant almost nothing. The environment was king, and the environment was going to program the genes to make 200 different human bodies. In fact, if you now program the possibilities of one gene with 200 outcomes and now multiply that by 25,000 genes, you're in the millions and millions and millions of potential outcomes for that human body based on its environment. Now let's look at this next generation since epigenetics, and that's microRNA. In a classic move in science, we as scientists took a look at the genome and said, wow, we only have 25,000 genes. And by a gene, I mean a segment of DNA that's going to make a protein. Wow, we have 25,000 of those guys. That sounds maybe like a high number to you. It's pretty pathetic when we thought we were going to find 200,000.
Yeah, 200,000.
What's that?
We thought there was going to be 200,000, but then the Human Genome Project came in and said, nope, it's 25.
Yeah, we finished a little early on that project. First project maybe in human history that got done early. But yeah, so we thought we were looking for 200,000 genes or more because we knew we had 200,000 proteins, and we thought one gene coded for one protein. Lo and behold, we only have 25,000 genes that code for over 200,000 proteins. That's a pretty pathetic number when you take into consideration a fruit fly, which was really the first genome that we untangled, only has 13,000 genes. So we're only a little less than twice as complicated as a fruit fly when it comes to genes. That's pretty pathetic on some level, but it's a good excuse. If you're feeling a little airheaded and out to lunch today, just say, hey, look, I'm doing pretty good considering I only have twice as many genes as a fruit fly. It's a good coping mechanism for your bad days. But the stunning reality is that 90% of the DNA doesn't code for a gene that's going to code for a protein. Over 90%. And so we just call that junk DNA. Oh my gosh, it's just like us calling 90% of the matter of the universe dark matter. Well, we don't know what that is. It must just be junk matter. And so we'll call that junk DNA. Well, in the last 5 years, it's become obvious that the junk DNA is doing something. And not surprisingly, it's the junk DNA that's actually regulating the 25,000 genes that actually make a protein. How does it do that? Each little strip of junk DNA makes a microRNA that's never going to code for a protein. Instead, the microRNA functions as a switch, and it now goes into the bloodstream and into other cells to turn on and off gene behavior. The stunning reality of your ecosystem and your human health is that 15% of the on-off switches in your bloodstream right now are not from you. They're from the bacteria in your gut and in the bacteria you breathe. Another full 15% are from the funguses in your environment. 30% of the on-off switches that are determining what gene is going to code for what protein is not even controlled by humans. Not any human source for that information. What does this mean for us as humans? We have got to get back in touch with our ecosystem. We have got to get a complicated ecosystem going back. We have to stop taking antibiotics ourselves for sure. We need to stop eating and spraying antibiotics all over our food and soil. We have to stop disrespecting this normal balance of ecosystem. We need to start getting back outside. Too many of us are jumping in a car in the morning, air conditioned to work, jump out, walk the 40 paces into an air conditioned office building, breathe crappy air all day, crappy photobiology, right? And so
my passion,
under all
right?
of those fluorescent lights, everything's falling apart. And then you get back into the same car, back to the same house. You may spend a total of 10 or 15 minutes outside in an entire day. And so we have to break these patterns. We have to make our workspaces look different. We have to really get people back out and injecting ecosystem back into their day-to-day lives.
Wow, that's all I can say. And I suspect that is a minor reaction compared to many people who've just watched this entire interview. So, and you can understand why, as I stated at the beginning, Zach is one of the most brilliant physicians I've ever met. And this is, I can assure you, because I spend a lot of time with Zach personally, this is just a fraction of what his knowledge and breadth of knowledge is. It's mind blowing. I just love spending time with him because I learn more and more. But obviously we can't give you the full details here. I mean, it would literally take tens of hours.
19 hours.
Yeah, 19 hours. Yeah. So I mean, it really does. And you've written a book, well, you're in the process of writing a book. I don't think it's finished yet. And it's certainly not
yet.
Yeah. So it's called Gut Bomb, I believe.
Yes.
And when do you anticipate having that available?
We hope to have that in the summer. So
okay, good. So we'll definitely have another interview before that and go over more details and help you with the launch on that, because it's such an important topic and you've got so much information to share. But I think the key is that you're really detailing the scope of the problem beyond what most of us even imagined it was, and then not just getting people frustrated and wringing their hands to say, what can we do? You're offering specific solutions that can turn this around, that can turn the tide, that can stop it so that we don't have to destroy the entire human species, which is literally the course we're on unless something changes.
It's absolutely true. Yeah. Absolutely true.
Thank
you for getting the word out there. We so appreciate, Dr. McCullough, what you do.
Yeah, we're partnering up for sure, because it's, I learned a long time ago that it's, you can't do this as a lone ranger. You have to collaborate with others who really have the information and they're doing the hard research in the trenches, as you are doing now. So, and you're getting incredible results, and we really can't go into specifics now, but there's lots more to share, is what I can assure you with a high degree of confidence. No question. We will definitely have you back for your launch of your book in the summer. So any closing words you'd like to part with?
Well, I think your closing sentiments are spot on there, and that we just spent an hour talking about cellular communication and bacteria. But what we get to see in clinic is that as soon as you put this bacteria communication network back into play, something dramatic happens to the human as we start communicating better. And so you're speaking now to the importance of collaboration and cooperation. And I think all of you right now listening already feel that, as if we don't band together and get this thing done, nobody's doing this for us. We outsourced our food, we outsourced our nutrition, and Monsanto is the product. So I think we are responsible, each of us, in a small way, for what Monsanto and the chemical companies became, because we stopped doing it ourselves. And so we need to take back that control. And how much power is that? And so we should be super mightily empowered as consumers to say, oh my gosh, with a little bit of collaboration, with a little bit of discussion, we can change everything. And that's what we'll do.
Absolutely. And thank you for helping us understand that even if those of us who are hyper vigilant and really never think that we expose ourselves intentionally to any glyphosate contaminated food, we're getting it through the rain. So there's some other specific interventions that we need to discuss in the future that can be helpful here. So thank you for everything you've done, you are doing, and will do. You're a great asset to the entire community to help restore health to the world. So you're deeply appreciated.